All right, let's do a quick example on computing log functions. Now, before we get there, we have to, if you haven't watched my inverse function video, I recommend watching that. So let me just review inverses first, okay? So if I have a function f of x, and it maps things from the left-hand side to the right-hand side, or from the domain to the range, what the inverse does is it takes things from the right-hand side to the left-hand side. So it takes things from the range to the domain. So you'll see my normal function will take x1 and it'll map it to y1. But what the inverse function, what it'll do is it'll take y1 and it'll map it back to x1. And same thing goes for all the other elements in the domain, right? So my normal function will take x2 and it'll map it to y2, but my inverse function will take y2 and map it back to x2. Okay, good. So if that was confusing, go watch my inverse function video. All right, so next. Right here, our function is an exponential function, a to the x. How do I know it's exponential? Because this x, our variable x, is in the exponent. This is a good way to identify if a function is an exponential function. So the question here is, what is the inverse of an exponential function? The inverse of an exponential function is the log function. So the inverse of a to the x is log base a of y. Notice how the bases have to be the same in order for it to be the inverse. Okay, so you need, if this is a, this also has to be a in order for it to bring the elements back to their original position. So another way of saying f of x is calling a y, right? So if I have y equals a to the x, then log base a of y can be rewritten as log base a of, remember, y equals a to the x. So log base a of a to the x. So if you have something that looks like this, log base a of a to the x, this log base a and this a here, all of this kind of cancels out or undoes itself, and all you're left with is just an x, whatever's in the exponent right here. So here's an example. So if my function here, my exponential function here is 3 to the x, the inverse function would be log base 3 of y. Notice how my bases are both 3. They have to be the same base, okay? Or else it won't work. And remember, just like before, I said f of x can also be called y. So what happens if I put 3 of x, 3 to the x, inside here in place of y? Well, if I have log base 3 of 3 to the x, my log base 3 and my base 3 for my exponential end up undoing each other or canceling out, and it ends up just turning back to x. See, what's happening here is you're kind of making a full circle, right? You're going from the left hand to the right hand, and then you're going back from the right hand to the left hand. That's kind of what's happening in this picture. Okay, so we know that the inverse of the exponential is the log function. Now, what if you're given the log function? What's the inverse of that? Well, it's the exponential, right? So if you have log base a of x, the inverse of that is a to the y. Again, make sure your bases are the same. If the bases are not the same, they won't match up and you can't undo the necessary components. So what does this mean? Remember, f of x, another name for him is y, right? We can also call f of x y. So in this statement, if I have a to the y, I can replace this y with log base a to the x. So I have a raised to log base a to the x, and this will just equal x. See, again, just like before, this a raised to the log base a, all of this ends up canceling out or kind of undoes itself. So all you're left with is whatever is inside this parentheses right here. For this question, for this example, it just happens to be x. So here's an example. If you have log base 3 of x. The inverse function for it will be 3 to the y. So if I put log base 3 of x into the exponent of 3 to the y, it's going to bring me back to my original function, which is x. It's crazy how it works. So let's just, it's good to know how these two are all kind of intertwined with each other, but let's take an example real quick. So given log base 2 of x minus 3 plus log base 2 of x minus 3 equaling 2, solve for x. Okay, so the first thing you should probably notice right off the bat is this. You have two same terms kind of added to each other. You have log base 2 of x minus 3, and you have the same thing again, log base 2 of x minus 3. So it's almost like saying you have x plus x, right? You have the same thing added to itself. So if you had x plus x, how would you simplify that? You would just say 2x. And in the same way, we're going to add these log functions. We're going to kind of combine them. So the way we combine them is we just say we have 2 log base 2 of x minus 3 equaling 2. So I combine the same terms. Makes my life a lot easier. Okay, so here's the other thing we could do. I have a 2 on the left side, and I have a 2 on the right side. Let's kill them. What I'm going to do is I'm going to divide both sides by 2. If I divide both sides by 2, then on the right-hand side, I'm just left with 1, and on the left-hand side, I'm just left with log base 2 of x minus 3. So remember what we're doing, we're solving for x here, but I'm so close to solving for x. However, the only thing is that x is stuck. It's stuck in this log function, right? So what do I have to do? I have to get rid of this log. I have to somehow get rid of it. But we already know from 2 seconds ago, to undo or to get rid of this log, I have to use the exponential function. I have to use its inverse. So what I'm going to do is I'm going to invoke this inverse law that we just looked at over here. Or I don't even know where it is actually. Right here, right? So if I take a raised to the log base a of x, I'll just be left with whatever's in the parentheses. So look what I do. So what you're going to do is you're going to put the left-hand side and the right-hand sides both in the exponent of 2. So why did I pick a base 2? Because I need both my bases to match up in order to get rid of this log base 2. All right, so that 2 I picked for these red 2's that I chose as a base were not arbitrary. I chose 2 because this was log base 2. If I have the same bases, they'll end up canceling out or undoing themselves. So if I put the left-hand side and the right-hand side in the exponent of 2, the left-hand side will simplify. I'm left with whatever is just left in the parentheses. So I have x minus 3, and 2 to the first power is just 2. So now it's just simple, right? I just solve for x. X equals 5. So hopefully that makes some sense. I know I rushed through a lot of that, but I have a lot of other videos on my pre-calc section, so go check them out.